Example 2.5 Electric flux through a cube. A cube that has faces of area A in a uniform electric field that is perpendicular to the plane of one face of the cube. What is the net electric flux passing through the cube? So here in this figure they have given you a cube and there is an electric field passing through the cube which is perpendicular to one face of the cube. And we need to find the total flux through the cube. We know that a cube has 6 faces. So if I want to find the total flux through the cube, I need to add flux through each of the 6 faces. So I can write total flux phi to be equal to sum of flux through face 1 plus flux through face 2, 3, 4, 5 and 6. Now we will write each of these values using the rule of flux. We know from the definition of flux, phi is equal to EA cosine theta. So I will write them as E times A cosine theta 1, where E is the electric field E, A is the surface area of the cube, which is the same for all the sides, and theta is the angle between electric field and the area vector. So we write this for all of them, plus EA cosine theta 2, EA cosine theta 3, plus EA cosine theta 4, cosine theta 5, and plus EA cosine theta 6. The magnitude of electric field and surface area of the cube remains the same for all the sides. We need to find what angle the area vector makes with electric field. So let's analyze each face of the cube. You have 6 faces of the cube and their area vector can be as shown in the figure. If you look at the figure, you will notice that area vector A3, A4, A5 and A6, they are all perpendicular to the electric field because the electric field is along the x-axis, whereas these area vector are along y and z axis respectively. So if they are perpendicular to the electric field, the angle theta that they make with the electric field will be 90. And we know that cosine 90 is equal to 0. So all of these term with theta 3, theta 4, theta 5 and theta 6, since they all make an angle of 90 degree, all of these term will come out to be 0. So flux through these 4 faces of the cube will be 0 and we will only be left with flux through surface 1 and surface 2. Then if you look at surface 1, the area vector points opposite to electric field because the electric field is going to the right and area vector is to the left. So the angle theta here is 180. Whereas for surface 2, the area vector is in the same direction as the electric field. So theta here will be 0. So let's substitute this to calculate the flux. Phi will be, we are only left with 1 and 2. So we write EA cosine theta 1 is 180 degree plus EA cosine theta 2 is 0. Cosine 180 is negative 1, so we get this as negative E times A, plus cosine 0 is positive 1, so we get this as positive E into A. And when you solve this, you get the total flux to be equal to 0. So the net electric flux passing through the cube will be equal to 0. Now there is a simpler way of solving this problem by using Gauss's law. We know from Gauss's law, flux through any closed surface is numerically equal to charge enclosed by the surface over epsilon naught. Now here there is an electric field passing through the cube, but there is no charge enclosed within the cube. And if there is no charge enclosed inside the cube, this term over here will become 0. And when you do 0 over epsilon naught, you get the flux to be equal to 0.